purpose of this podcast is to understand how to find the exact values of the trigonometric functions using the unit circle. And in previous podcasts, I've gone through and developed how you find the radian values, which are the pi values on the unit circle, and how to find the terminal points, which are the ordered pairs all the way around the unit circle. So I talk about, for example, why this is pi over 6, which corresponds to 30 degrees, and why the ordered pair is the square root of 3 over 2 and 1/2. So I'm not really going to cover that in this podcast, but what I am going to talk about is why, for example, the cosine of pi over 6 is equal to the x value in the ordered pair, square root of 3 over 2, and why the sine value of the pi over 6 is equal to 1/2. I'll also talk about tangent, cotangent, secant, and cosecant. Now, if you are unfamiliar with the unit circle, you can Google it and find several copies, different versions of this that you may want to print out just to have as a reference. Okay, when I start teaching trigonometry of real numbers, I oftentimes go back to what students learned about SOHCAHTOA in either their geometry or their Algebra 2 classes. A lot of us have heard of SOHCAHTOA before, and if you're unfamiliar with this, I don't know if you call it a mnemonic device, but if you're unfamiliar with it, SOHCAHTOA stands for sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. And it's a way that we can remember that if you're working with a right triangle has two legs and one hypotenuse. If you pick an angle that's not the right angle, so say for example you pick this one here, let's call that theta, then there are two legs. One of them is opposite and one's adjacent. And the two legs come together to form the 90-degree angle. But the hypotenuse is always the longest side opposite of the 90-degree angle. So if you were going to write a fraction of the three side lengths of a right triangle, let's say this is, now this is not really drawn to scale, but let's say this is 3, 4, and 5. For one, all three of those side lengths must work in the Pythagorean theorem. So 3 squared plus 4 squared equals 5 squared. But if I were to ask you what is the sine of theta, you would then pick 4 and 5 and write them in that order in the fraction. So 4/5. The ratio of the opposite over the hypotenuse is 4/5. And the cosine would be 3/5. Notice that both of those answers are fractions where their decimal approximations would be less than 1. Okay, now on the unit circle, our hypotenuse length is equal to 1. Okay, and if I put theta down here, the opposite side length is going to equal y, and the adjacent is going to equal x. Okay, so sine will equal y divided by 1, adjacent will equal x divided by 1, and tangent will equal y divided by x. And here's sort of how we go from right triangle trigonometry to the trigonometry of real numbers that uses the unit circle as sort of a way to understand the symmetry and the patterns of trigonometry. Okay, now if I were to take that sine fraction and take the reciprocal, I then end up with cosecant. If I take the reciprocal of cosine, I get secant, and if I take the reciprocal of tangent, I get cotangent. Now I've summarized that all here. And this would be something that I would have my student, you would find like in a pre-calculus textbook, and I would have my students take notes on it. All right, so if we call theta t, and t corresponds to the pi values on the unit circle, or the radian measures, and that t value is right in there, it's just a different variable, then the sine of t is y over 1, which is just y, cosine is x over 1, or x, tangent is y over x, which also corresponds to sine over cosine. And the reciprocal functions, cosecant is 1 over y, which is equal to 1 over sine, secant is 1 over x, and cotangent is x over y. So I usually tell students that they really have three things that they need to understand well when they're first learning about trigonometry. They need to know where the pi values are located, how to find the terminal point, and they need to remember what the 6 trig functions stand for. Okay, so for number one, the cosine of 7 pi over 6. First, you need to find 7 pi over 6 on your unit circle, which is right here. Then you need to be able to identify what the terminal point is. And for cosine, we're going to need to know the x value. Okay, so the x value in that unit circle would be this distance on the x-axis. And that distance is going to correspond with the x value in the ordered pair, which is negative square root of 3 over 2. Now, negative square root of 3 over 2 is the exact value. This corresponds with about 87 hundredths. And that's what you would find if you had your calculator in radian mode and you type in cosine of 7 pi over 6, you're going to get the decimal approximation, 87 hundredths. Okay. Now let's do the sine of 3 pi over 4. 3 pi over 4 is located in quadrant 2. It's right here. Sine is the y value, so I'm going to find the y value in that ordered pair, which corresponds to the distance on the y-axis. And that value is going to be positive square root of 2 over 2. Okay. Now let's try a couple of others. Number 3, the cosecant of negative pi over 6. Well, positive pi over 6 is this distance. Negative pi over 6 is going to be the same distance, the opposite direction. So this is moving in the positive, and then that one's moving in the negative direction, which really ends up being the cosecant of 11 pi over 6. They will have equivalent answers. Okay, now you need to remember that cosecant is the reciprocal of sine. So if we know what the sine value is at negative pi over 6 or 11 pi over 6, and we remember that that sine value is the y value, okay, we just need to take the reciprocal. We're going to end up with 1 divided by negative 1/2, which is equal to 1 times negative 2 over 1, which makes negative 2. Okay, now one little quick thing to note. Sine and cosine, because both of those come from opposite over hypotenuse and adjacent over hypotenuse, are always going to be values that are less than 1 or greater than negative 1. Okay, they're between negative 1 and 1. Secant and cosecant are reciprocals, and so those values are always going to be the hypotenuse over adjacent or hypotenuse over opposite, so their answers should be greater than or equal to 1 or negative 1. So greater than or equal to 1 or less than or equal to negative 1, I should say. And we did. We got negative 2 there, so that worked. All right, number 4, the tangent of 7 pi over 2. Now, you're not going to find 7 pi over 2 on the first unit circle. If you go all the way around the unit circle, that's a distance of 2 pi. If you go around again, that's a distance of 4 pi. Okay, 7 pi over 2, let's see, would be equivalent to, now 2 pi would be 4 pi over 2, and 4 pi would be 8 pi over 2. So that means we would make one complete revolution. That's 4 over 2. The top would be 5, 6. Down here, I would get 7 pi over 2. So it's going to be the same answer as what I would get if I found the tangent of 3 pi over 2. We call these coterminal values because you end up in the same spot and you're going to get the same trigonometric value. All right, the tangent is equal to the y value divided by the x value. So the ordered pair at that location is 0, negative 1. We have negative 1 divided by 0, which makes an undefined answer. So it is possible, especially in tangent, cotangent, secant, and cosecant, that you will get an undefined answer, that it's not possible to evaluate those trig functions at those t values. All right, last example. One other thing that we oftentimes do here is just pick one point on the unit circle, like for example pi thirds, and just find all 6 of the trigonometric functions. You can really see some symmetry here, especially if you analyze all 6 of them in quadrant 1. You can see some patterns that are really nice. Okay, so in order to do this, I need to know what the ordered pair is at that location. And the ordered pair at pi thirds is 1/2 square root of 3 over 2. 1/2 of is our x, square root of 3 over 2 is our y. The sine of pi thirds is equal to the y value, which is equal to the square root of 3 over 2. The cosine of pi thirds, which is equal to the x value, would be 1/2. The tangent of pi thirds is going to be the y divided by the x, which is equal to the square root of 3 over 2 divided by 1/2. And we really shouldn't leave that complex fraction like that, so let's multiply by the reciprocal. Square root of 3 over 2 times 2 over 1, which makes the square root of 3. Okay, now if I find the reciprocal functions, the cosecant of pi thirds is 1 divided by y, which is 1 over the square root of 3 over 2, or 2 divided by the square root of 3. If you rationalize that answer, it would be 2 square root of 3 over 3. Likewise, the cosine, the reciprocal of the cosine of pi thirds would be secant, oops, that's a 3, which is 1 over x, or 1 over 1/2, which makes 2. And then the last one, we want the cotangent of pi thirds. Now, if you know what the tangent of pi thirds is, you can just take the reciprocal of that. If you don't know what the cotangent or what the tangent is, you can then remember that cotangent is x over y. Go back to that ordered pair. We have 1/2 over the square root of 3 over 2, which equals 1/2 times 2 over the square root of 3, or 1 over the square root of 3. Okay, if you rationalize that ratio, you'd get the square root of 3 over 3. Okay. Now that 2 is not in the answer. Okay. So those are the 6 trigonometric functions at pi thirds. Now, I would continue on in my class and talk about things like where are the 6 trig ratios positive and negative in the unit circle. I would talk about reference numbers and how pi thirds, you're going to get pretty much the same answers, except some will be positive and negative for 2 pi over 3, 4 pi over 3, and 5 pi over 3, which are all referenced values. I would also teach how to come up with the Pythagorean identities. So those would all be things that go along with this particular unit of study. Thank you.